So, if you've spent any time at all working with AI, you've probably seen it fail in some truly bizarre ways, right? But what if I told you those failures aren't random at all? What if they're actually predictable patterns kind of baked right into the system's design? That's exactly what we're going to unpack here.
I mean, we've all been there. You get an output that just makes zero sense. And your first thought is probably something like, what just happened? That feeling of surprise, it's totally universal. But you know what? It's also a huge clue that we might be looking at the whole problem from the wrong angle.
All right, so let's start right there with that common experience of just surprising behavior. When an AI spits out a really strange answer, what's the first thing you think of? What words pop into your head?
You know, we tend to describe it in really human terms, don't we? We'll say the model got confused, or it made a mistake, or maybe it's just plain unreliable. And look, it's a totally natural way to think about it. But the thing is, that way of thinking completely misses what's really going on, the actual cause of the failure.
And that brings us to the most important mental shift we need to make in this whole discussion. The problem isn't the model's mind, so to speak. It's the mechanics of the system that's built around it.
So, on one hand, our gut interpretation is that the model is acting like a confused person. But the reality? The system is doing exactly what it was designed to do. That weird output? It's not a mistake. It's actually a consistent, perfectly logical outcome based on the system's own rules and limitations.
And this is a big one. This is why just fiddling with the prompt often doesn't fix the underlying issue for good. The failure almost never, and I mean never, comes from just the model itself. No, it pops up from the interaction between the model and the much larger system it's operating inside of.
Okay, so here's the crucial takeaway. We need a totally new definition of failure. It's not a sign that the AI is being smart or dumb or anything in between. A failure is simply evidence. It's a signal that we've pushed the system right up against one of its designed boundaries. The system didn't break its own rules, it followed them perfectly, right to the very edge.
So to really get a handle on the anatomy of a failure, we've got to look at the different layers of the system. Let's break down where these failures actually tend to pop up, shall we?
See, making these systems more reliable really starts with playing detective, figuring out which one of these layers is responsible for the weird behavior you're seeing. Is it a problem with the context window, the information it's retrieving? Is there too much randomness coming from the sampler? Was it a bad routing decision? Or did it just hit a hard-coded constraint?
Let me give you a few examples of how this plays out in the real world. A context failure? That can happen when your input gets too long and the model literally forgets the instructions you gave it at the beginning. A retrieval failure is a classic one. That's when the system pulls in outdated or just plain wrong information. Then you've got the sampler. If it's set too high, it injects way too much randomness, which is why you get wildly different answers every single time. And a constraint, like a safety filter, might just step in and completely override what the user was actually asking for. See? Every single one of these is a predictable system behavior, not some random fluke.
Okay, so what's the big payoff here? Why should you care about adopting this system-level view? Well, it's pretty simple. It's all about moving from mystery to clarity.
This right here is the key takeaway. Without a framework like this, AI failures just feel like these frustrating, totally random events. But as soon as you have a mental model of the system, those exact same failures suddenly become explainable. They become legible. You can actually point to a specific layer and go, okay, I see what happened there.
And once a failure is explainable, well, that's when you can start to reason about it like a professional. Recognizing these patterns is what lets designers, engineers, and operators actually analyze and manage risk. And trust me, that saves countless hours of debugging, which is pretty much impossible if you're stuck in that old mindset, thinking the problems are just random quirk.
Ultimately, it comes down to this. If you want to use these systems for anything important, for any real operational purpose, then understanding these system boundaries isn't just a nice to have. No way. It's the absolute non-negotiable starting point.
So to wrap this up, I want you to think about the systems you're building or using right now. As you look at that list of layers, context, retrieval, routing, and the others, which system boundary do you think is your biggest headache? Which one is the primary source of the failures you're dealing with? Because answering that question, that's the real first step toward making your entire system way more reliable.